Today we're going to talk about confidence intervals, and this comes from Chapter 7, where we're estimating parameters and determining sample sizes. Confidence intervals begin our journey into what we call inferential statistics. This is different from the descriptive statistics that we used before. Before we were just describing the numbers using statistical methods. Now we want to look at the numbers that we have and actually try to make inferences about the population. So we're coming to what we learned very early on in this course, where we want to use small sample sizes to make predictions about the population as a whole. This is in essence what most statistical analysis is all about. There are good ways of doing this and there are bad ways of doing this. And today we're going to be hopefully looking at some good ways of making that happen. So we'll start talking off by looking at estimating parameters and yeah. So the way that we set up confidence intervals is that we have a couple of key things that we start off with. And the first one is we start off with a point estimate. In this point estimate, we call it the sample proportion. This is what we get from our sample. If you're going to survey your class of 30 people, 16 of them are female, that is your point estimate, 16 out of 30, whatever percentage that is. That is your best guess of what the actual population proportion is going to be. So that's where you start. And then you create what's called a confidence interval that's around it. And that confidence interval can be based upon 90%, 95%, 99%. You get to choose the percentage. The industry standard is 95%, so that's probably what we'll use most of the time. And that confidence interval kind of gives you a window of variability that you could expect. When you're doing confidence intervals, what you're really talking about is the repeatability of your sampling technique. You want to be able to say that you are 95% confident that in the samples that you're getting, you actually have the true population proportion targeted in your sample. Let me kind of give you a visual of what I'm talking about here. This is a website called 538, and this is, you can go to 538.org or .com. And this is a current rating of Donald Trump's approval rating. And we can see that we have all this thick orange line here. This thick orange line represents the actual point estimate. And then we have a range of numbers, this other stuff that's going on here. And if we look at what we have down here, we have this estimate projection. This is exactly what we're talking about when we're talking about confidence intervals. We project the point estimate to be this thick black line, and then we have some wiggle room. And this wiggle room is going to be our margin of error. Here, 90% of we're using a 90% confidence interval. Now, this here is actually an amalgam of many polls that are taken. And what 538 does is it takes those polls and it rates them based upon how good they are and their past strategies and if there's any bias. And then they grade them, and then they find out the approval and the disapproval rating, and then they adjust them based upon how well their grade is. And then they also give them some weight too. We can see that the YouGov doesn't get a very good rating, but this Rasmussen report pulse opinion, even though it's a C plus, has a greater weight, and that's most likely to do with the fact that your sample size is much larger. All right, so let's go back to how we actually start creating these confidence intervals. Now we can do this for a proportion because it is an unbiased estimator. We learned about biased and unbiased estimators in the last chapter. And remember that proportion, the mean, and the variance are unbiased estimators, whereas the standard deviation, the median, and the range, those are biased estimators. So remember, we're using unbiased estimators here. Great. So before we actually look at an example, I want to talk a little bit about the variables that we have when we're using this. So these are the variables that you're going to have. You're going to have P, which is your population proportion. And then you're going to have P hat, which is your sample proportion. And remember, we're trying to use the sample to make a prediction about our population. Now, another key element to look at is the number of your sample values, your sample size. The larger your sample size, the better it's going to be. You also have this margin of error. This is what we're building when we're using to create our confidence intervals. And then we're going to talk about this critical value, and I'm going to show you how to find these critical values on StatCrunch. And this is a z-score separating the area from the right tail from the standard normal distribution. What we're going to do is we're going to look at how this looks on a normal distribution. We're going to cut off the tails, and where we cut off those tails is going to be these critical values. So when we build a confidence interval, this is how we do it. We start off with p hat right here, and then we add and subtract our margin of error. So we're going to get a low level estimate. This is kind of like when we look at the graph here, our low level estimate is going to be down the bottom of this orange part. It's going to be down here when we have our gray part down here, okay? When we have this p hat plus e, this is our sample proportion plus our margin of error. So now we're looking at when we have the high side or the upper end of our window. If we look at this little gray key that I have down here, it's going to be this part. Now the sample proportion that I have, I'm going to add and subtract that e. And this e, you can use this equation. Now we're going to use StatCrunch to create this for us, but understand that we're going to use our critical value. That's going to be based upon the amount of confidence that we want to have. We have p hat, which is our sample proportion. We have q hat, which is 1 minus p hat. Those two values add up to 1. And then we have our sample size. Okay? So it's pretty straightforward when you're trying to build your confidence intervals. But what happens is that we end up getting, this talks about the repeatability of our experiments here, or our sampling, is that we have these samples here. We have all of these samples, and we can see that, okay, let's say the true target proportion is 50%. We just know that, right? If we're going to flip a coin, half of it's going to be heads, half of it's going to be tails. But we know that from probability, you might get a run of heads and you might get a run of tails. And what's going to happen is that you're going to have some sampling where it's actually not going to be on exactly 0.5. You might get a run of one or the other. But most of the time, and not only that, 95% of the time, these confidence intervals that we generate are going to actually have this true population proportion within the margin of error that they establish. All right, let's go straight to the chase. And let's talk about a little bit before, let's talk about your confidence level and your Z alpha. Let's look at one of your homework problems here when we're asked to figure out your critical value. So we want to find a critical value, or Z alpha divided by 2, that corresponds to a given confidence level. And so what we're going to do is we're going to use StatCrunch to make this happen. And I'm going to use my normal probability distribution calculator. So I'm going to go to Stat, and I'm going to go to my calculator, and I'm going to go to normal here. And then what I'm going to do is I'm going to put my probability of 0.88 right here. And I'm going to select between. Well, 0.88 here. I'm going to use mean of 0 and a standard deviation of 1 because I'm using the standard normal distribution. We have these values of negative 1.55 and positive 1.55. These represent the z-scores that separate this section down here, my tail, from the rest of it right here. So my critical value, I have a z-score here, I have a z-score here. One of them is going to be positive, one of them is going to be negative. When we do critical values in this class, we're always just going to take the positive value. So I'm going to type in 1.55 here. Okay. And then that's how you do all of these. You just type in that in the normal probability distribution calculator. So here we have a confidence interval that goes from 0.111 to 0.555. And I want to find p hat plus or minus e. To figure out these values, we're going to understand that that point estimate is going to be exactly halfway in between. So we're going to use right here. We're going to find p hat. We're going to take the upper confidence interval plus the lower confidence interval divided by 2. That p hat is going to be the arithmetic mean between the two. For our margin of error, we're going to take the upper minus the lower, and then we're going to divide that by 2. So I'm not going to take the time to bust out a calculator for this, but if you add these up, divide by 2, you're going to get p hat. And if you subtract the big one minus the smaller one, divide that by 2, you're going to get your margin of error. Sorry, while I'm here, take these two numbers, here and here, and put them here and here. It's just another way of writing this confidence interval. All right, so now we're actually going to do a problem with a confidence interval. And we have this drug used to help prevent blood clots in certain patients in clinical trials. We have 4,491 patients treated with the drug. 183 developed adverse reaction to nausea. We want to construct a 99% confidence interval for the proportion of adverse reactions. So we're going to use StatCrunch to make this happen. So I'm going to go to StatCrunch. And I'm going to go to Stat. And in this time, I'm going to go to a new menu that I haven't done before. I'm going to use Proportion Stats, one sample with Summary. We'll do some data stuff later on, but for right now, we're just going to use Summary because we already know the aggregate data. So our number of successes was the 183 that developed nausea. And our number of observations was 4,491. And we want to construct a confidence interval of 99%. And that's it. That's all you're going to have to do to figure out and fill out for creating this confidence interval using StatCrunch. Okay? I'm going to go ahead and click Compute. And it gives you the numbers you need. It gives you your sample proportion. So I'm going to take that value, round it to 3 decimals, so that's going to be 0.041. And then it's going to, I want to identify my margin of error. Now to do that, I'm going to take my upper limit and then I'm going to subtract my lower limit and I'm going to divide that by 2. So I'm going to take 0.0483 I'm going to take this number here, this upper limit, and then I'm going to subtract my lower limit. I'm going to do minus 0.0483 minus 0.0331. I'm going to press enter first, and then I'm going to divide that by 2. If you have a graphing calculator and you put one minus the other divided by 2, it'll take that second number divided by 2 and then subtract it using your order of operations. So I'm going to get a margin of error of 0.008. And now I want to construct the confidence interval. Well, it's right here. We've got our confidence interval of 0.033 and 0.048. I know every time I type this in, it disappears, but we can see there's our lower limit and then there's our upper limit. This is the nice thing about StatCrunch is that it gives you everything you need. Now, this standard error we don't actually use in this class, but that standard error is just from that square root of p hat q hat divided by n. That is that number. And then that's it. So now here's the statement that we really want to get after here. We want to write a statement that correctly interprets the confidence interval. Remember, it talks about the repeatability of this experiment. So we want to look through and we want to say one has 99% confidence. So we want to look at, and it's going to be part C. One has 99% confidence that the interval from the lower bound and the upper bound actually does contain the true value of the population proportion. This is what you really want to key in here, is this part where it talks about true value, kind of like the hardware store. We want to be able to target the actual population proportion. Okay. And that's going to be it for all of these for creating your sample proportion confidence intervals. In this problem here, there's a lot of data that's going on here. You actually should just ignore all of this and just understand that 5 of them are red. So when you do your actual confidence interval, just understand that you're using summary data with 5 and 40. All right. And that's it. In the next video, I'm going to talk about finding sample size to get the amount of confidence that you need.